again into Glover Bintex and Science TV. Today we are going to look at the experiment on using water drops to measure the viscosity. Our main aim here is to investigate the nature of viscosity in liquids, determining of viscosity coefficient using Stoke'S law. So just as we've been doing always, I'm going to use a virtual experiment laboratory. So we have our own resources or the apparatus. We'll be using an oil, that is paraffin oil in a glass cylinder, water filled in glass burette. You'll have your stopwatch and a measuring tape or a ruler. So here is the procedure on how we'll be using. As you can see there, the procedure of the method: you will pour your oil into a glass cylinder, then you pour water into a glass burette. Ensure that you fasten that glass burette so that its tip is in the oil. Remember that the oil that we are using is a paraffin oil. We are using a paraffin oil. We have two types of oil. That is a paraffin oil and the other one. So you collect the water droplet, place a beaker or container underneath a cylinder. So here we want to count the number of water droplets that are passing through the marks or between the marks of a glass cylinder. Remember that your glass cylinder is calibrated, and so when you let water droplets out of your glass burette, you will count the number of droplets anyway, so that you know how many of them pass through the marks of the glass beaker. And again, you have to take the measurements. So how are you going to take the measurement? Just as I've said, you let the water droplets develop and fall through the oil, thereby by opening the burette. And you must begin as soon as the first drop occurs. Set the stopwatch. Continue counting the drops until you hit a certain threshold. For example, you can hit 20 drops. But for this experiment, I don't want to say that we are going to hit 20 drops. Only allow 20 centimeters cube. Only allow 20 centimeters cube of water to pass from the burette. So when the 20th centimeters cube is obtained, stop the stopwatch. And therefore, you'll be noting the duration and the total number of droplets that has passed through the marks or between the marks in the beaker. Remember that the marks that we are considering are two marks that are calibrated in the beaker. And up to that point, we are going to show you the formula of calculating the coefficient of viscosity using Stoke'S law. Okay guys, before that, let us look at this experiment here that I was explaining. This is my burette, and I've filled it up to the 0 centimeter mark. And this is my paraffin oil, and this is a triple stand, this is a stand. This beaker here contains that paraffin oil. So you will just be releasing, you will open the tap slowly, and then you will be counting the number of drops that are passing through between these two marks here. You can choose either of the marks because the marks are the same. So you let the drops to pass through until the water level becomes up to 20 centimeters cube. So this is what I was explaining. This is the procedure. So at the same time, we can talk of our procedures having maybe measuring using your stopwatch the time of water drop between the marks on the cylinder. So when one drop falls or passes these two marks, you will record using your stopwatch. And at the same time, we will be repeating this for 10 drops. Why are we repeating them for 10 drops? We want to measure the accuracy or the actual time that will be taken by one drop to pass between the two marks. So for 10 drops, we'll just take an average of those 10 drops to find your value T. Okay, I want you to consider this formula of Stoke'S law of finding its coefficient. We said that N is equal to M minus the density V, then you multiply by you multiply, or I mean divide by 6 pi RV in bracket 1 plus 2.4 R over R. Consider this one down, where M is the mass of the average drop, then rho is the density of oil, whereby our rho is given by 0.8 grams per cubic centimeters. 0.8 grams per cubic centimeters. Then R, our small r, is the average drop radius. Then V is the average drop radius. Then V is the average velocity of water. Then we have, maybe you might be given 2R, which is equal to 4.5 centimeters, whereby R is the radius of the cylinder. R is the radius of the cylinder. So this is the radius of the cylinder. So you might be asked to find the coefficient of this viscosity using Stoke's law. After all, you know how to calculate the diameter of a the diameter of a water drop, and etc. All these values given here. So these R, you can get it from these 2R. Then velocity of water, you will calculate it from the volume. You know very well that mass of water is being given as, if density is given as mass over volume, so mass is given as volume times density. You have the volume of that drop, which was 20 centimeters cube. So this 20 centimeters cube, you will count the number of drops. For you to get the volume of one drop, you will say that if 20 centimeters cube is equal to the number of drops that you counted. Remember that you had number of drops that you counted at that particular time. What was one? One drop. So that one drop will be getting its volume. So you know very well that our density is given there. Density of water is given by, the density of water as 1 gram per cubic centimeters. You can use that 1 gram per cubic centimeters to find your mass, to find the mass of water. After all, you'll be getting all the values, then you'll be inserting them into this particular equation. Therefore, you will find your coefficient of viscosity using Stoke's law. And remember that the density of oil was given as 0.80 grams per cubic centimeters. Then drop of radius, at least the radius of a drop you should be getting as 1.71 millimeters, that is for water. Then your drag terminal velocity should be 13.07 centimeters per second. 13.07 centimeters per second. And after all, the coefficient, ensure that your coefficient is ranging between, let me say 0.7 or 692 0.74. But actually mine I got as 0.71. This was my N, coefficient of Stoke's law. Anyway, remember to like, subscribe, and share for this channel to get more experimental devices. Thank you so much.